Teichgräber. I'm a PhD candidate at the Department of Economics at the University of Zurich. And I would first like to thank the organizers for having me today, because I think this is a great approach to science communication, which I really like. And so today I would like to tell you about the 2020 Nobel Prize in Economics, which was awarded to Paul Milgrom and Robert Wilson, both from Stanford University, for their work on auctions. And I agree that auctions may appear like a bit of an abstract setting. So where have you seen auctions? And many of you think of some kind of online auction maybe, because I'm sure most of you have bought something online on eBay or Ricardo or wherever, like this Rolex, which is up for sale and currently stands at 25,000 francs. But the Royal Swedish Academy of Sciences says the Nobel Prize is awarded for the improvements to auction theory and inventions of new auction formats. So did they really award the Nobel Prize just to help us to sell and buy stuff in online auctions which are secondhand? And the answer is no, not really, because auctions are really everywhere. So today I want to tell you a bit about what we think about when we think of auction theory, and that it really circles around the analysis of strategic behavior of bidders, and then that auctions are really prevalent in many settings, and we often don't even realize that we just participated in an auction, and it really helps to make the economy more efficient. So let me tell you a bit about auction theory. Well, when you think of bidding on something, you might wonder, how much is this object really worth? And let me lead you through this with an example. There's a watch for sale. So I want to sell my watch right here. It's not a Rolex. It's not as much worth, but I still want to sell it. There are two bidders, A and B. And well, how much is it worth to them? They might think, well, we have what is called private values. A thinks it's 10 francs worth to me. B thinks I'm a watch lover. This is 15 francs worth to me. But really those values could be independent, and they just have independent tastes for watch. So this is their private component. But then the watch value can also have a common value. So let's say the watch just has a collector's value, which is identical to both A and B. And both A and B form a guess about that value, which A says, okay, I think the collector's value is 10 francs, while B says, I'm optimistic, I think it's 15 francs. But they all just think it for themselves. And so those are really important concepts for auction theory, because bidders make strategic behavior, and that very much relies on how much they value that object. And Robert Wilson worked on this theory of common values, and Paul Milgrom incorporated a very comprehensive theory of both private and common values and made very general results on that. So they did some fancy math and just showed for various concepts of valuations how different auctions work. So what kind of auction formats are out there? Well, the easiest one is probably the first price auction. We're still selling that watch here, and each bidder just submits one sealed bid. And the bidder with the highest bid wins and pays their bid. So if A says, I think it's 10 francs worth to me, and B thinks, I think it's 15 francs, and A says, okay, then I bid 8 francs, and B bids 14 francs, then B actually wins the auction and pays her bid, which is 14 francs. So, but what if there was a common value to this watch, like the collector's value? What if it's actually only 12 francs worth, but B was just over-optimistic about the value of the watch? What happens is that B paid too much, and this is called the winner's curse, because B paid 14, although the watch is only worth 14 because she was too optimistic. And then she's actually worse off by bidding and winning the auction compared to not participating in the auction at all. And this is a really important issue because this leads bidders who anticipate this to just bid much more defensively. And that in turn will reduce the revenue for the seller. So this winner's curse is especially prevalent in the first price auction. But it also appears in the so-called second price auction. In the second price auction, each bidder submits one sealed bid again, and the bidder with the highest bid wins and pays the second highest bid. So here, if B says, I bid 15 francs, A says, I bid 10 francs, then B wins and has to pay the bid of A, which is 10 francs. And again here, if the common value was 12 francs, well then there's no winner's curse because B paid only 10. So this winner's curse is already less likely to happen in the second price auction, but it can still happen. And now Milgrom actually showed that there's an even better auction format to mitigate this winner's curse, which is called the English ascending auction. In this auction format, bidders can increase their bid each round. This is a dynamic auction. It's not just a one-shot. If bids are not raised anymore, the bidder with the highest bid wins and pays this highest bid. So let's say we have 3 bidders, A, B, and C. They all have their private guesses about how much that object is worth. It might be some common value component like the collector's value. It might be some private taste. B just really likes watches. C is also a fan of watches. A not so much. And they start bidding. A says, okay, I'm bidding 5 francs. B raises to 8. A raises to 9. C raises to 10. And now A thinks, okay, I think it's only worth 10 francs. I'm not gonna bid higher than that. B raises to 11. And then A thinks, okay, 11 is too much. I'm out. Now C realizes that A is not raising his bid anymore and thinks, maybe A left at 11 francs, so maybe my guess that it's actually worth 13 francs is wrong. Maybe it's actually worth less because A already left the auction. So I'm just not going to bid more. I'm out. And then B has the highest bid with 11 francs and wins. The auction has to pay 11 francs. If that true value, common value was actually 12 francs, then there's also no winner's curse in this setting. And what the work of the Nobel Prize winners showed is that in an ascending auction, bidders can learn each other's information and bid more confidently. So if they have this dynamic process of observing each other's bids, they learn from each other, and that makes them more confident about the actual value of the object. And then they bid more to what their guess, closer to what their guess is about the value. And this was a really important result because you have this winner's curse is a problem in many auctions, and to just get around this is really important. But now it sounds like the English auction is actually just the best auction out there. It also has some drawbacks, like it enables bidders to collude, to kind of communicate with each other throughout the auction and then to collude. So this is not so clear which auction is best. And that's why auction design is actually a tough issue, because the right choice of auction to sell my watch here in the best way, that's not so easy. And now I just told you what kind of strategic things we think about when we deal with auction theory. But let's see where it is applied, because now I only showed you the example of this watch, but in practice, auctions are really, let me say, everywhere. For example, Google makes a lot of, or most of its revenue through advertisements. 2019, that was 134 billion US dollars. And where are those advertisements placed? For example, if you search for something on Google and you just type in some word, then often advertisement appears. And every time that you, or most of the times that you look for something on Google, there's an advertisement, there's an auction running in the background, because really those companies who want their advertisements to be placed participate in an auction which determines where they are ranked. And those are called ranking auctions. So every time you look for something on Google and there's an advertisement popping up, there was an auction which determined which advertisement showed up. Then also in auctions in the power grid, getting supply and demand together in the power grid is not an easy task. And there's a national company in Switzerland which is taking care of that. It's called Swissgrid. And they auction electricity to neighboring countries because Switzerland often has excess electricity, and then they sell it to other countries through auctions. But the government is employing auctions a lot, like for example spectrum auctions. You've probably heard of 5G technology. It's the latest thing to have very fast data transfers, and for the use of 5G technology you actually need to send it on different frequencies, and those frequencies are owned by the government. And in 2019 the Swiss government sold the use of those frequency bands and made 380 million francs, which were paid by Swisscom, Sunrise and Salt. The Swiss market is rather small. In Germany they made 6.6 billion euros of profit through that. And the government uses auctions all the time. For example, now at this point, because of Corona, the government is pumping a lot of money into the economy to help business stay open and so on. And they somehow need to get this money from somewhere, so they need to take a loan, and they do this through auctioning off government bonds. And then to just get those loans, they use auctions. Also, the European Union is auctioning off their emission certificates, and the government is using auctions whenever, or many times, when they want to have a bridge, highway, railway built. An auction determines who actually gets to build that bridge or that highway and how much is paid. And those are called procurement auctions. And here it's really important to choose the right kind of auction, because the government really wants to hand this deal to those bidders who actually make the best out of it. So who will best be able to build that highway or to use those frequencies, to most effectively use it. And the work of the Nobel Prize winners really helped to make this possible, that the government can work much more efficiently. And I just showed you very simple examples so far of how auction theory works and what it deals with, but it gets much more complicated when we talk about multi-object auctions. For example, for those 5G frequency bands, there are many different frequencies that can be used and that were sold. So we have multiple things that were up for sale in this auction. And then for bidders it's really hard to determine how much that's actually worth, because it's like, is the 700 megahertz band, is it just how much is that worth? How much is it worth combined with another one? Do I need all of them? Well, how much are all of them worth to me? How much are only two of them worth to me? It gets really complicated. And so Milgrom and Wilson got their work also for the invention of new auction formats. And that was precisely to also tackle these kinds of issues, because those auctions get extremely complex, and they came up with smart auction formats which really rely on the theory that I showed you for selling only this watch. But it's really clever, and it really helped to raise revenue and to also hand out the objects more efficiently. So let me conclude and tell you that auction theory is part of an area which is called market design. And this really is about whenever we want to set the rules for a market, how do we proceed? Well, in this example with auctions, the government or the auctioneer selects some kind of auction format, and then the bidders make their strategic decisions on how much to bid and how much is it worth, place their bids, and then there's an outcome of the auction. But what market design is, and therefore also auction theory is really concerned with, is you want to target a specific auction outcome. Like really you want to maybe raise revenue if you're Google, or you maybe want to hand the object to the one who makes the best of it, and that will benefit society. So you pick some auction outcome, then you anticipate what strategic decisions of people will lead to that auction outcome, and then you think one step back, which auction format will guarantee that bidders make those strategic decisions which lead to the outcome that I want. So this is some kind of reverse engineering, and this is studied heavily by economists, computer scientists, and engineers. So the work of the Nobel Prize winners really opened up research in many different areas. And if you want to check out who works on market design and auction theory in Zurich, check out marketdesign.uch.ch. And really what I want you to take away today is that the Nobel Prize was awarded to Milgrom and Wilson because their work paved the way for the successful use of auctions that improved efficiency in many markets, despite us often not being aware of it. Thank you very much.